Hey everyone, in this video I want to work through number 8 in your packet, and I'm going to go kind of quickly through it, so if you need to pause at some point to get caught up, make sure you do that. The idea here is we're trying to minimize the distance between the curve y equals square root of x, that's the red graph, and the point 3/2 comma 0. So if I were to connect the graph and the point with a line, I could find the distance of that line. And I want to find the location on the square root of x graph where that distance is as small as possible. That's what I'm minimizing. So to do that, I need a distance formula. And we luckily have a great formula for distance called the distance formula. So we do square root of x2 minus x1 squared plus y2 minus y1 squared, which means I need 2 points. I have 1 point, 3/2 comma 0. The other point is going to be the point on that graph. Well, I don't know much about that point other than that it'll be some x location and it'll be some y location, but I don't want to use the letter y. I have a little equation I can use because the y value will always be square root of x. Just like we were doing on those other problems where we're creating the rectangle. The y value is just what the y equals equation is. So those are my 2 points. And so when I plug into the distance formula here, I have distance equals square root of, and I'm going to plug in my first, if I do x coordinates subtracted from each other, I'd get x minus 3/2. And the y coordinates subtracted from each other would be root x minus 0. And then I need to expand this out. So that's going to give me, when I expand out the x minus 3/2 squared, I'm going to get x squared. And then you multiply this, the 3/2 and the x, and double it. So 3/2 times 2 is just 3. So it would be just minus 3x plus 9/4. And then plus square root of x squared is just x. So we get distance equals square root of, that looks like x squared minus 2x plus 9/4. And that's what I'm going to be minimizing. That's my distance formula, and I want to find the smallest distance, so I'm going to minimize that. All right, so let's take the derivative. We'll get d prime equals, it's square root of x, so you're thinking this to the 1/2. So I got the 1/2 in front, and then this square root, or x squared minus 2x plus 9/4 to the negative 1/2, and then I have to times it by the derivative of the inside, which is 2x minus 2. All right, so then let's rewrite this. So this is going to be d prime equals 2x minus 2 on the top over 2 root x squared minus 2x plus 9/4 on the bottom. And I care about when the derivative is 0 or undefined. And so when the derivative is going to be 0 when the top equals 0. So for d prime equals 0, that will come from 2x minus 2 equals 0. So that gives me x equals 1. So now we're actually going to be able to ignore the bottom equaling 0. And the reason why is it actually never will equal 0. And if you think about it, so that square root is the distance formula part, right? That's the same as this original distance formula. And think about what that distance is representing. It's on my picture, it's these purple lines. That purple line will never equal 0, right? Because that distance between 3/2 and the graph is always some distance. So the bottom's never going to equal 0. So my only critical number is x equals 1. And I can do my number line test with that. So I'll make my number line here. And I know that my critical number here is 1. know the distance is never going to equal 0. I don't really know a lower bound, but we know the distance will never be 0. And then upper bound, well, I don't really care what the upper bound is because I want to know about what's happening at 1. I want to show that that's a minimum. So we don't even really worry about that upper bound. And so then I'm going to test between 0 and 1 and between 1 and something bigger than that on my derivative to figure out the signs. So the bottom, we already said, is always positive. So if I plug in something smaller than 1, I'm going to get a negative over a positive, right? 2 times like a half would give me a negative on the top. So I know distance prime is negative, which means distance is decreasing. And then if I plug in something bigger than 1, like 2 times 3, I get a positive on the top, positive on the bottom. So I have a positive derivative, which means we're increasing, which means 1 is a minimum. So min at 1. And so we can kind of finish off with our statement that since d prime of 1 equals 0 and d prime changes from negative to positive, there is a min at x equals 1. And the last thing we want to do is kind of make sure we answer the question. So this one says minimize the distance. So really, I guess I want to find what is that minimum distance. The other thing sometimes you'll be asked is what is the coordinates of the point where the distance is minimum. So let's write down both of those things. So to find out the point, I know the coordinate. I know the x coordinate is 1, and if I plug square root of 1 is 1, so the y coordinate is 1. So that point is actually the point 1, 1, where that distance is minimized. Right? And what would the distance be? Let's plug it in. D equals, let's see, I have this distance equation right there. Square root of 1 squared minus 2 times 1 plus 9 over 4. So that'd be 1 square root of 1 minus 2 plus 9 over 4. And we just simplify this. That'd be negative 1 plus 9 fourths. So negative 4 fourths plus 9 fourths would equal 5 fourths. And I'm running out of room here. Equals 5 over 4, square root of 5 over 4, which is root 5 over 2. And so that would be your minimum distance, root 5 over 2. All right, I hope that helped. You can find some pretty good videos on YouTube for a few more examples if you wanted. Just kind of Google calculus optimization distance, and you should come up with some good ones there. Thank you for watching.